All right, we're going to have a little bit lighter day today with not very much homework, but there's a few words. There's actually three words when it comes to probability that we need to understand. The first one, mutually exclusive, we talked about it. We'll try to flesh it out a little bit more and make it a little bit clearer today. Complementary and independent, these are new things. Days like today are when I really hate Corona because I had a fun activity planned where we play some, not garbage can, but I get out the recycle bin and we play some basketball in class. And what happens is everybody gets two shots with the free throw. And what happens is the first time people take a free throw, roughly, I'd have to make up some numbers, but about 50%. So we'll say about 0.5, about 50% of the people make the free throw. But what happens is after the first shot, they actually learn a little bit and they get better. And the second shot is a bit better. We'll just call it 0.75. And then we look at the probability that someone actually made both. So they made the first one and they made the second one. And usually it's somewhere right around 40% of people actually can make both shots. So 50% make the first, 75% you get a little bit better because you made the first one, make the second, and there's about 40% who make both of those. Well, this little idea in here about how one event can influence another is with the idea of dependence and independence. Okay? An independent event, if you have independent events, what that means is the events do not influence each other. They're independent. And events don't influence each other. So my example with shooting free throws is an example of dependent events. You shoot one free throw, and the fact that you learned something on the first free throw and got better, that's an influence. It helped you be a little bit better on your second one. So those are dependent events. Well, remember what we learned a couple days ago. We had the probability, let's just call this first event, making the first free throw, we'll call that event A, and making the second free throw, we'll call that B. Remember, we said if you wanted to find the probability that both A and B, both of those things happen, the way that you do that is that you take the first probability and you multiply it by the second probability. And they should, if you multiply the two probabilities, you should get the probability that both things happen. So let's take a look at these events. Now, I understand that I just made them up, but in class, you do get similar numbers. So let's multiply them. You see 0.5 times 0.75 is equal to 0.375, which is close, but it's not 40%. Okay? So because this math did not work out, where you multiplied your two probabilities to get this intersection, because that didn't work, that means we have dependent events. There's events that are kind of influencing one another. Well, maybe it'd be helpful to have an example of things that are independent. So how about you can go grab any coin if you want, and let's say you flip that coin 100 times and you get tails 100 times in a row. It's a miracle. You get tails 100 times in a row. Well, what's the probability that you flip tails or heads on the next flip? That's 50-50. All those previous flips meant nothing because they are independent events. What happened in the past does not influence the future. Well, watch what happens. Let's try flipping a coin. If you flip a coin, and we're going to do it twice, what can happen is you get heads, you can get heads, tails, you can get tails, tails, and you can get tails, heads. Okay, so let's figure out what's the probability that you flip heads twice in a row. Well, you flip heads twice in a row. Here it is, boom, boom, 1 out of 4. So I can see that the probability is 1/4. Now let's use our probability formula. Well, our probability formula says what's the probability you flip heads one time? 1/2. What's the probability you flip heads on the second flip? Also 1/2. And 1/2 times 1/2 is 1/4. And what you see how the math worked out? 1/2 times 1/2 is equal to 1/4. And the reason that that the math worked out is because those are independent events. If somehow one flip of the coin would influence another, you would see that this math would not work out. So what's the test for independence? Events are independent. if I independent, if I could spell, it'd be right. Independent. And we're going to go if and only if P of A times P of B is going to be equal to probability of A intersect B. Okay? So what you're going to do, multiply your probabilities, find the probability on its own without math. Just look it up in the event. We'll do that in a second in an example. So multiply the probabilities and just find the probability on its own with no math. If the math works out, they're independent. If the math does not work out, they're dependent. Let's check it out. All right, down here we have a circular spinner. I mean, a dice, a spinner, whatever. It's got 6 regions, so if you want to call it a dice, you can. But it's a spinner into 6 congruent sectors, numbered as shown. Consider spinning it twice, so similar to rolling 2 dice. And assume the spinner cannot stop on a boundary line, so you're always going to get a number and not in between. All right, so I'm going to ask you these questions. Are these mutually exclusive? Are they complementary? And are they independent? And that right away makes me see we didn't fill out complementary. Complementary means their probabilities add up to 100. Probabilities add up to 100%. So the probability you flip heads, 50%. Probability you flip tails, 50%. Because those two probabilities add up to 100, those are complementary events. Okay, so they go together to create an entire probability of everything that could possibly happen, the whole 100%. All right, so these are the 3 questions. Are they mutually exclusive? Are they complementary and independent? Let's check it out. Well, here's the first event, and let's just take them one at a time. Let's see. The first spin stops on an even number. So let's find P of A. If I want to find the probability that it stops on an even number, well, I'm looking at 2, 4, 6. There's 3 of them out of a total of 6, so I have a probability of 1/2 that that's going to happen. Let's look at probability of B. The spin stops on a multiple of 3. Well, the only multiples of 3 I see are 3 and 6, so that's 2 out of 6, which is 1/3. Let's find probability of C. The spin shows a number less than 3. So less than, it says strictly less than 3, so not 3. You have 1 and 2, so there's 2 of them. We have 2 out of 6, which is equal to 1 out of 3. Last one, probability of D. Let's find that last event. The sum of the spins is less than 5. Well, the sum less than 5, it's hard to think about, so I'm actually going to get my dice paper out because I can see, I mean, whether you spin a dice or spin a spinner or roll a dice, it's the same. So let's figure out how many of them have a sum that is less than 5, because this would be the same. So here is a sum. Here's one example, 2, 3, 4, 5, 6. And these are equal to 5, so it looks like there's going to be 6 out of 36, which has a probability of 1/6. So here are your probabilities. All right, quick review. What does mutually exclusive mean? Mutually exclusive, we drew a Venn diagram, and the Venn diagram was completely separate, meaning they had nothing in common, meaning they cannot happen at the exact same time. So 2 events would be like you flip a coin one time, and you get heads and tails. Well, you can't do both. You either get heads or tails. You can't do both. So those are mutually exclusive events. Some things can happen at the same time. We talked about having doubles and a sum of 10. You can do both of those. You can have doubles and you can have a sum of 10. So those are not mutually exclusive. So let's talk about A and B. Are they mutually exclusive events? So can it happen where the first spin stops on an even number and the second spin stops on a multiple of 3? Well, if the first spin stops on an even number, that would be like 2. And the second one, 3, would be an example. I'm just going to write it like a coordinate point. So even number and multiple of 3. So I found an example where those 2 things happen at the same time. So because they happen at the same time, we're going to say, no, these are not mutually exclusive events. They can happen at the same time. Are they complementary? I'm just asking you, do their probabilities add up to 100%? So 1/2 and 1/3 do not add up to 1. They're not complementary either. Are they independent? Is one of these events influencing the other? Okay, this is probably the hardest one. Are they independent? So what you do is we're going to do this. We're going to multiply their probabilities and see what we get. So we're going to multiply probability of A, which is 1/2, and we're going to multiply the probability of B, which is 1/3, and we're going to get 1/6. Easy enough. Now, the test for independence comes this, and this is where it's hard. You have to go to your information and figure out what is the probability that both events happen. Well, let's figure this out 1 second. How many ways are there for this to happen, where the first spin stops on an even number and the second spin stops on a multiple of 3? Well, we found one example, 2, 3. 2, 6 is another example. So there's 2 ways. Let's see, the first in, so how about 4, 3? That's an example. And 4, 6. And then hopefully the last one we can think of is 6, 3 and 6, 6. Okay, so what we just found is we just found 6 different ways that you can do these 2 things at the same time. You can have the first spin stop on an even number and the second spin stop on a multiple of 3. So what's the probability that that happens? Well, the numerator is going to be 6 because there's 6 different options that can happen. How many total possibilities are there? Well, it's actually the same as throwing a dice. There's 6 by 6, which is 36. So there's 36 possibilities. So there is a 1/6 probability. So here's what I see. When I did multiplication, I got 1/6. When I went to the data and I looked at the events and found it by hand just by looking through the points and sifting through the data, which is it's tricky, I also got 1/6. So because those 2 numbers are the same, the math says 1/6 and digging through the data says 1/6, we're going to say yes, these are independent events, meaning, yes, they are independent. Meaning, just because the first spinner stops on an even number, that has no... That's bedtime at the Rosenbus. Just because the first spin stops on an even number, that has no bearing on what's going to happen on the second spin. All right, I'll get you started on the next one. I'll pause it and we'll do it together after that. So, are C and D mutually exclusive? Can they happen at the same time? The first spin shows a number less than 3, and the sum of the spins is less than 5. So can we do that? So the first spin shows a number less than 3, for example, 1, and the sum of the spins is less than 5, 1. So those 2 things happen at the same time, so no, they are not mutually exclusive. Are they complementary? Let's take a look at C and D, look at their probabilities. I'm just asking, do they add up to 100%? They don't. So the answer is no. They don't add up to 100%. Are they independent? Well, let's check it out. First, let's do the math. Let's just do quick probability calculation. 1/3 times 1/6 is going to be equal to 1/18. So you have it. Now, let's dig into the data and see if it's actually a 1/18 probability. Let's see how many ways there are. And this, like I said, this is difficult to do. So C and D, we want the first number to show a number less than 3, like 1, and the sum to be less than 5. So let's see how many ways that we can do that. So we have 1 and 1, and we have 1 and 2. It's got to be less than 5, 1 and 3, but not 1 and 4 because that's equal to 5, not less than 5. All right, now let's go to the next number. We have 2 and 1, 2 and 2, but not 2 and 3. After that, we have 3 and 1, but not 3 and 2. So it looks like there's 6 different ways where we can have the first number is a number less than 3. I can see I already messed up. This last one should not count because it says it should say less than 3. So the first spin shows a number less than 3, and the sum of the spins is less than 5. So it looks like there's actually 5 ways. So there's a 5/36 chance that that could happen. Okay? So what that means is, if you limit your spins to only numbers that are less than 3, that is going to have an impact on what the sum of those is going to be. Because you forced the first spin to be a low number, that influenced the second event, which is your sum. Okay? These numbers are not equal to one another. That means these are dependent events. Somehow, some way, these events are influencing one another, and we just proved it mathematically. All right, actually, your homework is to just, we're not going to do any bookwork. We're just going to do this and do example 2. You don't need to take pictures or anything. I'll post some answers. You can check your work yourself.